Welcome back, everyone. Today we are starting one of the most important chapters in the entire AS Mathematics course, coordinate geometry. Now, most students think this chapter is about memorizing 4 or 5 formulas: midpoint, distance formula, gradient formula for parallel and perpendicular, equation of a line, the bisectors. But Cambridge doesn't ask formula questions. Cambridge asks thinking questions about shapes and stuff. And by the end of today's lesson, you will realize something surprising. Every single straight line question in coordinate geometry comes from one simple idea, and that is the relationship between 2 points A and B. That's it. Once you truly understand that, the formulas become almost obvious. So today we are not memorizing, we are understanding. But before we begin, let us remind ourselves where we are. We have already completed in our previous lessons functions, composite functions, inverse functions, the transformation of functions, and 2 lessons on quadratics as well. Those chapters taught us how equations behave, how straight lines behave, how the parabolas behave, what happens when you are taking the inverse, what is it a reflection on. Coordinate geometry asks a different question. Instead of asking what is the equation doing, it asks where is the equation, right? We're now putting together algebra onto the coordinate plane. So let's start with drawing 2 axes. This is the vertical axis or the y-axis or the dependent variable axis, and the horizontal one is the x-axis or the independent variable axis. Now, so let's say we have a point A, a coordinate 4, 3. Now, what information does this coordinate 4, 3 actually tell us? So it shows us that the this point is 4 units horizontally away from the origin and 3 units vertically away from the origin, right? Now, a coordinate is simply an address. However, if coordinates are addresses, then naturally Cambridge begins asking how far apart are 2 addresses. Let's say another address is at B, which is 2, 6. So 2 units horizontally from the origin and 6 units vertically from the origin. So now Cambridge is going to ask how far apart are these 2 addresses, which is the distance between these 2 addresses, right? What's exactly halfway between these 2 addresses, which is going to be the midpoint? How steep is the road joining them? So if you're moving from A to B, right, in this direction, or if you're coming down from B to A in this direction, then what is the steepness like? And everything else follows naturally. So we are going to begin with the midpoint. Now let me put 2 coordinates here on the Cartesian plane. So this xy plane is also called the Cartesian plane. So let me put 2 points here on the xy plane, right? So let's say A is -4 and 2. So let's say A is -4, 2. So this is A, and B is, let's say, 8, 10, right? So let's say B is 8, 10. So right here. Now, if 2 friends walk towards each other at exactly the same speed, so that means that if A starts to walk towards B here in this direction, and B simultaneously starts walking towards A in this direction, right? Where will they meet? Provided that they're traveling at exactly the same speed, then you can say that they're going to meet at exactly halfway between their addresses, which is going to be at this particular point, right? So from horizontally, so between 8 and 4, what point do we have between 8 and -4? So this distance is 12 together. So halfway is going to be horizontally 6 units away from A and 6 units away from B, right? So 6 units away from -4 is 2. So this point is going to be 2, or 6 units away from B from here is also going to be 2. 8 minus 6 is 2, right? And then vertically, it has to move from 2 to 10. And what is the difference between 2 and 10? It is 8, and halfway of that is 4. So 10 minus 4 is 6, and 2 plus 4 is also 6. So this distance is 4, this distance is 4, and this is 6, right? So it has to meet at 2 comma 6. So midpoint of AB is going to be 2 comma 6. And what have we done? So the formula therefore is going to be, so we did the, so first of all we took the difference of them, so 8 minus minus 4, which was 12, we divided it by 2, right? And then we added it to negative 4, right? So if I try to do it, so this becomes, so eventually if I take 8 as x1, if I take minus 4 as x2, and I divide it by 2 and I add it to negative 4, which was x2, so this is going to become, if I take LCM, x1 minus x2, so sorry, this is plus, and this is going to become plus 2x2 upon 2. So this is nothing but x1 plus x2 upon 2, right? And likewise, the formula for the midpoint of y on the vertical is going to be y1 plus y2 upon 2. Therefore, the midpoint of AB, if A is x1, y1, and if B is x2, y2, it is nothing but x1 plus x2 upon 2 and y1 plus y2 upon 2, right? Now notice something, we didn't use magic, we simply averaged the 2 points, right? Now let's say, so let's do a past paper example. Let's say there's a point M. I'll draw a line in order to separate the sections. Let's say there's a point M which is 3 upon 2, 3 upon 2 comma 11 comma negative 11. Okay, now let's say that this is the midpoint of P, which is minus 7 comma 4, and Q, which is unknown, that is A and B. Now solve. If I have to find the values of A and B, all I have to do is apply the formula. So the midpoint is going to be 3 upon 2 comma negative 11 is equal to x1 plus x2, which is A minus 7 upon 2, and y1 plus y2, which is B plus 4 upon 2. And now I just need to compare. So I compare the x coordinate with the x coordinate, that is this A minus 7 upon 2 is equal to 3 upon 2. So this is going to be A minus 7 is equal to 3, or A is equal to 10, or for B, I am going to do B plus 4 upon 2 is going to be equal to negative 11, or B is going to be equal to negative 26, and that's it. So our coordinates for Q is going to be 10 comma negative 26. That's it. Now whenever midpoint is given, multiply by 2 first and then subtract, faster than simultaneous equations. Okay, now let's say that you have, in another example, you have a midpoint given as 6 comma negative 1, and the known point is 2 comma 7, right? So you multiply it by 2, right? So once you multiply this by 2, this midpoint by 2, so 12 minus 2, and then you subtract 2, so you get 10 for x, and then you multiply minus 1 with 2, so this becomes minus 2, and then you add and then you subtract 7, so this is going to be minus 9, and you can apply the formula as well. So the coordinate is going to be 10 comma minus 9 of this other coordinate which was unknown, right? So if midpoint tells us halfway, distance tells us how far. So now we are going to do the formula for distance, which is nothing but a concept derived from Pythagoras theorem. Now let's say that again we are given a Cartesian plane, an xy plane, and there are 2 points. Let's say point A is x1 y1, and point B is nothing but x2 comma y2. Now if we were to find out this distance, all I can do is I can make some rule lines. So if I do this, and if I make this line, and if I make this line, and if I make this line, so this is going to be y1, this is going to be y2, this is going to be x1, this is going to be x2. So if I have to find out this distance, this is going to be y1 minus y2, right? And if I have to find out this distance, this is going to be x1 minus x2. And you can So just to clear it, for example, x1 was 8 and x2 was 2. How would you find this distance? This is going to be 8 minus 2, that is 6, right? So just giving you some instead of a hypothetical or unknown quantities, I gave you those numerics in order for you to understand it. Now, these are vertical lines, right? So I drew vertical lines here, right? So if this is a vertical line, this is a horizontal line, therefore this is going to be a right angle triangle. And since this is a right angle triangle, I can apply Pythagoras theorem, right? And what does the Pythagoras theorem say? It states that base square plus height square is equal to hypotenuse square, right? And hypotenuse is the distance AB, and if I square it, this should be equal to base square, which is x1 minus x2 whole square, plus height square, which is y1 minus y2 whole square. Now you in your books you would see x2 minus x1, and which is one and the same thing. I mean, a minus b whole square is same as b minus a whole square, because you are taking the square of a distance, right? So it doesn't really matter however you write it. Okay, now, so we are going to do x1 minus x2, or x2 minus x1 whole square plus y1 minus y2 whole square is equal to AB distance square. Now, in order to get rid of the square on AB, I can take the under root on both the sides, so it cancels this, and we are not going to have a plus and minus because lengths or distance quantities can never be negative, right? So therefore the distance of any point is under root of x2 minus x1 or x1 minus x2 whole square plus y2 minus y1 or y1 minus y2 whole square, right? So this is how you use the Pythagoras theorem to derive the formula. So we are not memorizing, we are just simply using Pythagoras. So now let's do a few examples for the concept to be to get strengthened in your head. So if this here is your this is our x-axis, this is our y-axis. Let's say there's a point right here which is, I don't know, which is 1 comma 6. So let me call this A, which is 1 comma 6, and B is 7 comma 2. So B is 7 comma 2. Now, in order for us to find out this distance, this is pretty easy, right? How do we do it? We just apply the formula 7 minus 1 whole square plus 2 minus 6 whole square, which is minus 4 whole square, that is 16. So I will just write down minus 4 whole square. So 36 plus 16, and you take the under root in order to find the distance of AB. So and the notation that we use is we put AB inside the modulus, right? So this is going to be under root 52, or we could write it as 2 root 13, right? And now let's try to verify it through the Pythagoras theorem, right? So this height is nothing but 4. This base is nothing but 6. So 6 square plus 4 square under root, that is root 52, which is same as 2 root 13, right? Pretty easy. Now, never simplify signs early. Keep the brackets in, because most mistakes happen because students forget that negative 3 whole square is not negative 9. So negative 4 whole square, we use that as a positive 16 rather than negative 16, because if you had done it, you would have subtracted 16 from 36, which was 6 squared, and this would have given you an answer of 2 root 5, which would have been a huge mistake, right? So now we know halfway, which is the midpoint. We know the distance, so we have done midpoint. We have done distance, right? So the next question is, how steep is the line? I mean, the line could be like this. The line could be more gentle. The line could be more steep. The line could be in a negative direction, right? The line could be steep negative. The line could be gentle negative. So now we are going to do all of that. So this section is called the gradient, and we are going to do parallel and perpendicular and bisectors, all deriving from the gradients. Of course, bisector doesn't have to do with gradient, but when we try to find the equation of a perpendicular bisector, then in order to find the gradient of a perpendicular, the gradient of an original line is used. Okay, so now Let's so if I try to make three roads, let's say this is road A, which is absolutely flat. There's no steepness, and then there's a flatter road. So there's some angle, but it is flat. And then there's a steep road, right? So this is a steep, this is gentle, and this is flat. So and what how were we finding the gradient in our O levels or GCSE? So it was change in y over change in x. So we take how much does the y quantity change per a unit change in the x quantity. So as we can see in this road A, whatever change is there in the x quantity, whether you're moving from here to here, or you're moving from here to here, or you're moving backwards from here to here, there is no change in y. So the change in y is 0 no matter whatever the change is in x. Therefore this is just going to be 0. So the gradient for A is 0, and change in y may be written as y2 minus y1, and change in x can be written as x2 minus x1. Now you can do y1 minus y2, but then you have to take the corresponding value as well, right, for x1. So if it is y1 minus y2, then in the denominator you have to write x1 minus x2, because signs really matter in gradients, right? Because the sign change flips this steepness into this steepness, completely opposite, right? So we have to make sure that we are not confusing that. Now, so what does gradient really measure? It's not just the use of a formula, but it measures the steepness. So now, and we also call this change in y over change in x. It is, and I'm pretty sure you guys have done this, rise over run. So how much does it rise when you run by a single unit? Okay, so the positive is when your change in x. So if your change in x is positive, and if your change in y is also positive, then the gradient is like this. So you move one unit in the horizontal direction, and you move certain units in the y direction. It could be 0.8 in the y direction, or 1.8 in the y direction, or 100 units in the y direction, right? It could be anything. Okay, now however, if the gradient is negative 0.8, then what is it actually? So this is negative 0.8 over 1, or 0.8 over negative 1. Now we know that this is nothing but change in y over change in x. So this one is that change in x is 1 unit, and change in y is negative 0.8 unit. Okay, so we are moving from here point A to point B. So we are like this. Okay, now, and this 0.8 over minus 1. So we're moving negative 1 unit here and 0.8 unit here.